Hello, hello. All right. I'm guessing we are live. Yep. Cool. Then welcome everyone, or better said, no one at this point. But yeah, hopefully in the future someone will be looking at this and it will be useful, right? So my name is Greg. I'm right now doing some coding challenges in this site called CodeSignal. I'm doing it in different languages, primarily in Java, JavaScript, and Golang. And yeah, so I've been doing it for a couple of days already. And right now we are on the second part of this arcade journey that the site presents. And cool, then let's continue where we left, right? So in this case, it was this other problem. On the left, we have the problem statement. And on the right is where we need to implement the solution. In this case, there are these type of problems that limit the solution that you may implement. And yeah, so here we need to do it in one line, for instance, right? This is why we need to do it in the ellipses, that it's called. Let's read it out, okay? Small disclaimer, these are bits or bit operations. I'm super bad at it. I'm trying to get better, but we may need to look up for some hints in the either or in our solutions or in the internet on how to solve certain things. Cool. Let's jump into it. Let's read it. The description, right? So you're given an arbitrary 32-bit integer and take its binary representation. Maybe let's just share this out. Okay, yeah, take its binary representation, split bits into it in pairs, bit number 0 and 1, bit number 2 and 3, etc., and sub bits in each pair. Then return the result as a decimal number. What? Okay. Let's see the example, right? So for n being 13, solution should be 14y because you have these two, right? So we need to swap these two, and then we need to swap these two. Okay. No clue. No. All right. Looks like we have some spam in the chat. Okay. So how do we do it, right? I mean, I'm guessing we can do it maybe recursively, right? Let's see how. Let's see. We need to see. So if n equals 0, then just return oh wait, it's kind of easy, right? Because we only need to do, so it's only going to be either 1, right? So let me show you what I mean. So return something like this, right? So switch, wait, how do you switch statement? JavaScript, I forgot. What's the right syntax? Okay. All right. So yeah, something like this, right? So it's going to be. Oh, let me do this. String. Okay. So in this case, it's going to be like this, right? Wait. Switch. Expression expected. Huh? What can you do? Let's see. Case 1. Let's just see. Does it work? No? What if we do it like this, right? That's it? Okay, then we will need it to do the old way, right? With like with this ternary operator. So in this case, 0 would be 0, and then n equals 1. Then it needs to return. So if we have 1, then we have 1, then we return 2. And then if we return so if it's 2, then we need to return 1, right? And if n is equal to 3, then we need to return 0. Why? Because of this, right? Oh well, I cannot add the thing. Oh wait, can I add it? No, I cannot. Okay. And then else just return something else. Why? Because you only have, it's either 0, meaning this one. Sorry, it's either 0, it's either 1, it's 2, or it's 3, right? In the binary representation. In all of that, the reverse are this one. Sorry, then this is. Oh wait, no, sorry, it's swapped, not reverse. Okay, so 0, 0 is this one. Then with 1 is 2. Then with 2 is 1, and then with 3 is 3, right? So, and then otherwise, if it's none of these, then we will need to what? Then we need to then we need to do what? We need to do solution, right? Of n 4 plus solution sorry, 4, right? So from one we solve this, and from the other one we shift everything to the right, or we can do this, right? So so like this, 1, 2, right? So it should be the same, I think. Okay, what is wrong with this? Let's see. So yeah, no, then this needs to be sorry, it needs to be 1, 2, 3, and yeah, so this gives us the last 2 digits in binary, and then we move 1, 2, and then we continue and do the same, right? But so this one should be what, times 10? No, times 4. This one should be movie 2, right? I would like to because this will give us this one, and we need to move the solution that we have here. Yeah, maybe let's see. Test. Does it run? And those need to be reverted. Okay, okay. Yeah, we can do it, and then we make it one liner, right? So cool. So if n equals 0, then return 0, right? If n equals 1, then return 2. If n equals 2, then return 1. And if n equals 3, then return 3, right? So because it's the same. Okay, so to do it, we need to do the get this the solution. I mean, to solve it with the previous 4 lines, to do the AND with 3, so we get the last. Where do I have the AND? Yeah, so we get the last, sorry, the last 2 bits, right, from the number. So with this, we will do it for the last 2. And then, how do we do it for the other ones? So yeah, this will work. I mean, for some cases in this, pretty sure that it's just the ones. Okay, 0, 1. But then what? Uh, we do this and then what? We move. This one to the right. Do we sum it up? Let's see, right? So cons temp and then cons extra, then temp extra, then console log, temp extra, and right. Let's see. Okay, so with the input of 13, right? So we have this. Sorry, so n to string 2. Sorry, and then this needs to be moved to, right? And then let's also check what is the this one. For this one, we don't need it because oh well, let's might as well do it, right? So we get okay, it works, yeah. Not bad, right? So yeah, in this case we have okay extra. Right, so we have let's see this case, right? 13, which is this one, and then we got the extra, meaning this one, and then we have this one that is the one on the left, right? Because we moved it to the left. Cool. I wonder for this other case, 74, right? How does it look like? So for the first one, 74, the extra on the right, yeah, it would be 1, right? Because initially it would be these 2. Okay, the extra is okay. Then we have the temp extra, which yeah, then it comes and solves this. You have 18, you move it, and then it gives you this one, right? So it shifts this one and it continues. Then you have this one, just shift it, and then you have this other one. Okay. Now let's do it in one line, right? Let's comment everything here and uncomment this one. So 0, 0, and 1, 2, then 2 is 1, and 3 is 3. Then solution is this one plus the solution Yeah. Let's see. If it doesn't work, then it's a problem with the ternary notation, right? So we have this one, then everything else needs to be, okay, so turn this one, and then if not, then everything else is this one, and then if not, the last part is this one, right? Yeah. See? What? Wait, I need to also grab this one. Oh, what's happening? Okay, so let's see. 0, return 0, else check if n is equal to 1, then return 2. If not, n is equal to 2, then 1, else n equals 3, return 3, right? Else do this solution, move these two, then get this and the and then do the sum of these two. Maybe this is no, it should work. Why it's not working? Well, interesting. I've thought that this bitwise operator was executed before the plus, but apparently not. Okay. Now submit. Okay. So apparently I opened this one yesterday, that's why it's taking so long. Okay. What is this? So you have what? One. Okay, so you get all of these. Okay, of course, makes so much sense, right? So you get all of the bits that are on the left, and then move them one or shift all of them to the right. Then you get all of the ones that are on the right, and then move all of those to the left, and then just do the OR, and then you solve it, right? Makes so much sense. Right. Yep. Let's probably maybe simplify that with that. There is wait, can I do this? Okay, I cannot. Yes, so we have yeah, the and and what was this? binary number JavaScript. Pam, pam, pam. Pam, 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 pam. So how was it? OXAAA JavaScript? Was it something like that? Okay, so this is exactly the same thing. All right, so we have these ones, and then after this, shift everything to the right, and then R, then I will probably have to do this in here, right? And then do the same, but the other way around, and then okay, and then this one, right? So this should also work, yeah, and it's way faster, of course. Right. So this one moves all the ones from the left to the right, and this one moves all the rights to the left. Nice. Okay, now implement the missing code, right? Again, one-liners, not the most fun to do, but it's always good to learn new things, right? Like this other tool of shifting bits from left to right was pretty cool. Right. So let's read it out and we will close this session of today with this one. So you're given two integers, n and m, right? Find positions, find position of the rightmost bit in which they differ in their binary representation. It is guaranteed that such a bit exists, counting from right to left. Okay. So return the value. Yeah, second position of the found bit. How do we do it? Um, mm, I don't know. Um, so in this case, mm, I mean, I'm also thinking recursively, but I don't know, you know? Probably, yeah, doing it recursively, it's definitely not the way to go because of what we saw in the previous problem, right? There needs to be some solution that it just consists of manipulating the bits, right? Mm, so in this case, the answer is to the 4 because we just do this, right? I mean, what do we do if we get the complement, right? So imagine that, let's use this example, right? So the example of 0, 0, this one, and then 1, 1, 1 should throw 1, 1, 1, right? Because this is 1, 2, 4. No, wait, so this should be the one, right? Ba-bam. And then, so if we move this to be the complement of each one should be something like this. And then to do this, right, so we do an XOR, right? So because if we do this one, XOR this one, it will throw us this value. Okay, nice. So then let's do it, right? So we will do XOR, where do I have this? The cap, okay? And then, oh wait, let's see if it just works without. No, wait. First, let's do it with and then without. All right, let's run it. Doesn't work. Oh, wait, it doesn't work because, yeah, this works because it doesn't have anything on the left. But what if there is more, right? So if there is more, then the XOR itself only, it won't work. Okay, so do we, how do we? So wait, okay. So I mean, why this won't work? Because taking this last example, right? Imagine that here we have, I don't know. Let's put it like this, and then we have like this, right? If we do just that XOR, it will return this this one, right? Right, and this is not valid, right? So because it needs to still return this other value. So I guess one way to do it is to do, so you have this, let's just continuous. So you have this, then we take the complement, right? Then just do +1. Then this gives us 0, 0, 1, right? Sorry, yeah. No, sorry, this will give us okay, yeah. So this will give us this, and then if we do an AND with this, then we will get what we were looking for, right? Did I? Yeah, this works. Okay, I don't know. Is it too complicated to ground? Let's see, right? So we do the XOR first. Then on top of that, we will do. Wait, is there a simplified way of doing it? So what if we only do the last thing, right? So we do the last thing. Um, we do what? Plus one. Then this becomes. No, it's okay. I think we need to do the whole thing. And then we figure out, hey, external, what's up? Breaking my head with these bitwise operators. Um, okay, so yeah, I think this should work, right? So we do the XOR as we were saying. It's called CodeSignal. Let me paste the URL in the chat. Um, you're welcome. Yeah, this side has this arcade section where they just put together several problem groups, and right now we are doing the ones relevant to bits, bit manipulation, which I'm not that good at it. That's why it's fun to practice. Okay, so let's do it, right? So we were at this point, we got this. Now what we need to do is get a complement of this, and then on top of this, one more, and then let's do the AND of the initial XOR, right? Let's see if this works. Perfect. Excellent. It worked. Now, I'm pretty sure there is a simplified version of it, and we are about to check it out in here, right? Okay, so, okay. Let's see all of these lowest 1 bit. Okay. What is this property? So, okay. Yeah, right. So let's maybe go back to our code. Right. So if you make the XOR, let's just check the solutions, right? So the solution was an XOR M, and then yeah, bitwise operators. And then it was this minus and XOR and sorry, XOR, right? And why this works? So taking this example, what it's doing is returning this wait, let's use this, right? So it's returning this. Let's and then it's doing and then if we do this, it should do this case would be what? It transformed this into this, right? But sorry, if we do the with the minus, I think the representation of this is what? It's all minus one, right? I don't know. The AND operator is like this, right? So if you have this, it will return you always, sorry, it will return you 0. And then if you have 1 and 1, it will return you 1. So if you have, let's say, the integer, let's call it, 3, which is the binary representation of 3 is 11 or 1, 2 ones. Then and then if you have, in this case, the integer 2, no, sorry, then the binary representation of 2 is 1 and 0. When you do this, just the AND alone on integers, it does the following, right? So AND 3 and 2 AND, it will return you this this thing, right? So the result would be 2. Yeah, exactly. Yeah, it's just what it do, right? So it goes into the bit representation or the binary representation of this and applies this the logical operator. Correct. Yeah. Yeah. Exactly. But on the binary representation or on the bits of the integer, right? The OR is different, right? So the OR is, so you have this, and then it goes into 1, and then you have 1, sorry, it's 1, and then you have 0, or 0, it returns just 0. That's different, right? So for the OR, whenever you have a 1 in either side, it will always return you 1, and it will always return you a 0 if there's only zeros. And for the XOR, you have like XOR No, the XOR is whenever there is a difference. So if you have XOR 0, it will return you 1, and whenever you have 1 XOR 1, it will return you 0, and whenever you have 0 XOR 0, it will return you 0. Right? And the XOR is generally expressed or used with this, with the, I don't know how is it called, in English. I know it in Spanish as the little house on top. Sí, en español. Do you speak Spanish? Yeah. I don't know the name in English for that. Ah, mira, mucho gusto. Yo soy de México, pero estoy viviendo aquí en Bilbao. Ah, mira, bueno. Entonces, así queda. Eh, deja, guardo por aquí la explicación, la pongo en el chat. Bueno, no tiene mucho formato en el chat, pero pues ya, ahí quedó. Entonces vamos a hacer esto. Vamos al que sigue. Um, ah, ah, pero estoy hablando en inglés porque también necesito practicar el hablar inglés. Que voy a cambiar de regreso a hablar inglés. Cool. So, I mean, you can write your questions in Spanish, and I can answer them. Yeah, exactly. It's all about practice. That's what I'm saying. Cool. So here on the left, we have, again, the problem statement, and on the right, we will have the editor part where we are going to do the solution, and yeah, same drill, right? So in this case, whenever you have this template for solving the problem, you need to do it in one line, and let's find it out. I don't have, but maybe after the stream and I can maybe create it. You know? Okay, cool. So you're given two integers, right? So n and m. Find position of the rightmost pair of equal bits in their binary representation. It is guaranteed that such a pair exists, counting from right to left. Return the value of 2 position of the found pair, 0 place. Of equal bits in the binary representation. Okay, so in this case, how do we do it? So you have n equals 10 and m equals 11. The output should be 2. Why? Because you have 10, 10, and then 10, 11. The position of the rightmost pair of equal bits is a bit at position 1. Find the right binary representation. Okay, but why does it say rightmost pair of equal bits? So in this case, it should be this 2, right? How do we do it? Let's see, right? So we have this thing, and then we have 11, and the result, it needs to be 0, 0, 1, 0, right? Okay. Uh, but in reality, so if we would have uh, this one and sorry, and this one, it should be sorry. P of 10 B2. Right. Hmm. But so in this case, it will need to be this one, right? Because it says pair, right? Or um, what if we have this? Sorry, this one, this one. This should be. Sorry. Ah, yes. Sorry. This should be this one. This should be this one, and this should be. So no. What? No. Okay. So this is this one. This is this one. So this should be. Sorry. This one, and this should be this one. Right? Because uh, in this case, it's the the rightmost pair of equal bits is 1 0, and it's on the position 1. And this one, the rightmost pair equals is in this case 1 and 1, and it's in the position 2, right? And in this one is the 10 because it is these two. Oh, man, it's complicated. I don't get it. I don't fully get it. Position of the found pair. Okay, so let's see, right? We need to make sure um, okay, so in this case, how do we only get the how do we eliminate everything that is different? We do it with an and, right? So in this case, 10 and this one, so this one, this returns 1 0 1 0, right? No, but this doesn't work because yeah, an and is not the solution. How do we get it? So do we have mm, well, I don't know. I need to go and grab some lunch. But yeah, let's continue with this next time. And yeah, I wish you all have a great week. See you later. Bye bye.